Greetings. Let us talk about the principles of electrosurgery. Very important in the endoscopy unit. These are my acknowledgements, and today's learning objectives include the following. We will learn about the principles of electrosurgery, determinants of current density and its impact on the tissue. So, in the endoscopy unit, during the procedure, you see this large polyp, a pedunculated polyp, and then you decide to cut that polyp. And this polyp needs electrosurgery unit, and we go ahead and set it up. And we will learn about how to set up the electrosurgery unit, but let us learn about the principles of electrosurgery first. So here is a polyp, and in order to cut the polyp, you need to generate heat, and that heat will cut the polyp. How does that happen? You need an electrosurgery unit, and you start and pick up a program that will generate a particular type of electrical current. And in a circuit, you need two things. One is a dispersive pad that is placed on the patient's back or loin, and then attach it to the electrosurgery unit to the neutral outlet. And then you take a snare which has an electrical outlet and connect it to the monopolar slot. So you have all the ingredients. You have the generator. From the generator, you have a cord going to the snare. The snare is around the polyp. And if we were to generate the current to go through this and create a circuit, you have a dispersive pad that will disperse the energy back to the electrosurgery unit. So how do we activate the electrosurgery unit and start the circuit? So this is typically done by pressing on the foot pedal, either on the yellow pedal or the blue pedal, depending upon whether we want to produce a cut or a coagulation effect. And when you press on that, the circuit is completed. So what does the circuit include? The generator creates a voltage, that is the power to push the electrons through the circuit. So the electrons are flowing from the generator to the snare, and from the snare to the tissue, and then back to the generator via the dispersive pad. Whenever the circuit meets some resistance, here the resistance is the polyp stock. As the current is flowing through, the temperature increases, and if the temperature increases fast or slow, it will decide whether it's going to create a cut or a coagulation. And the dispersive pad helps in cutting the temperature down as it completes the circuit. At this point, I would like to introduce the concept of Ohm's law. Ohm's law is a relationship between the flow of current, the voltage, that is the force that is moving the current through a circuit, and R is the resistance. So it's basically about the flow of current and the force that is pushing the electrons through, and the resistance of the tissue. So let us look at some concepts. So as you can see, there is a voltage that is forcing the electrons to go along the path, and R is the resistance. In this case, if you think about the snare around a polyp stock, and I is the current that is going through. if you increase the voltage, there is more current flowing through that. And that might increase the amount of heat generating as it meets the point of resistance. And if there is increased resistance in the pathway, either because of scar tissue or fibrous tissue, then the amount of current that is going through will be less. In that case, if you want to compensate for that, you want to increase the voltage. So these are the principles to keep in mind. And let us talk about two concepts: coagulation and cut. Electrosurgery can do two things. Either it could coagulate the tissue or it could cut the tissue. And how is it going to happen? So let's talk about coagulation. So we start with the electrosurgical generator, generating a voltage, and electrosurgical generator creates a radio frequency alternating current that goes through the circuit, and wherever it finds that current density from that snare around that polyp, it does heat up the tissue, and it is the degree of heating up and the speed of heating up determines whether the tissue is going to go through a coagulation effect or a cut effect. If the temperature rises to less than 100 degrees and slowly, the tissue goes through slow dehydration, and that results in coagulation. On the other hand, if the heating up of the tissue happens pretty fast and goes above 100 degrees centigrade, there is vaporization or boiling of the tissue, and then that results in a pure cut. So we've learned two important concepts here, coagulation and cut. And let me summarize it here. Coagulation, there is slow dehydration of the tissue, and the temperature that is reached is less than 100 degrees. On the other hand, for a cut, there is rapid vaporization of tissue, and the temperature goes above 100 degrees centigrade. And at this point, if you have a very high current density, that means you squeeze the polyp stalk pretty tight. The current density is pretty high, and then you can have pretty high temperatures happen very quickly, and you can have a cut. On the other hand, if you close the snare very, very slowly, and there is a slow development of current density, then there is more coagulation before it cuts. So depending upon whether you want to have a cut or coag, it also is important not only what current you use, but how tightly you close the snare. So let me take one step further and talk about the voltage. It's the force that pushes the electrons through the circuit. And depending upon the peak voltage that is generated, you will have different effects on the tissue. So let us look at voltage and also cycle, whether there is a continuous cycle or there is interruption of the cycle for the cells to cool down before they get hit again. Whenever there is a cool down in between cycles, you could expect coagulation. So let us look at it. Here is a probe that is, or you could say, wire of a snare touching the mucosa. And right now we are not producing any circuit through this area, but if you set it to less than 200 volts, less than 200 peak volts, it results in a soft coagulation, very superficial coagulation. It doesn't go too deep. And this is used for coagulating blood vessels during dissection of the submucosa. It can be used to ablate the mucosa, and it is safer to treat bleeding and other other things that you don't want to create deep thermal injury. So less than 200 peak volts, soft coagulation. If it goes beyond 200 peak volts and the cycles are continuous, it results in a pure cut. So less than 200, more than 200. Soft coagulation, pure cut. On the other hand, if there is interruption in the cycles, only 50% of the cycles are active. It is known as 50% duty cycle, and that results in not only cut but also some coagulation as the tissue cools down and then tries to heat up slowly. If you cut down the duty cycles further down to 6%, you will have more coagulation. So we learned about the peak voltage, less than 200, more than 200, whether it creates coagulation or a cut, and the interval between and the cycle interruption. Is it 100% cycles, 50% or 6%? That determines the amount of coagulation. So let us review this one more time. So soft coagulation, less than 200 volts, peak volts. Pure cut, more than 200 peak volts. Blend, that is 50% or 6% duty cycle, gives a combination of either a blend, cut and coag, or more coag. Okay. So let us take one step further. There are different ways you can use coagulation, and it all depends upon the voltage, right? We've learned already with soft coagulation, it is less than 200 peak volts. With force coagulation, it goes between 800 to 1800. And there's something called a swift coagulation. Here you have very high voltages from 660 to 250 peak voltages. And how do these three different varieties of coagulation affect the tissue? Soft coagulation, force coagulation, swift coagulation, in terms of the depth of injury and the speed of injury. Soft coagulation, very superficial, very slow coagulation. Forced is intermediate, and swift is fast and deep. So depending upon what we are doing in electrosurgery, the endoscopist will decide which way to go. Lastly, I want to talk about current density, otherwise known as the amount of concentration of the current at a particular point. In polypectomy, if you want to have a clean cut, and you could use what we call a very tight closing of the snare, and in addition to that, there are a lot of different parameters that influence current density, and let us talk about it. One obviously is how much is the voltage and the frequency of the current, and the type of electrode in terms of the size of the snare wire that you're using, and the amount of tissue that is entrapped by the snare, and how long is the current going through, and finally the resistance of the tissue. All these parameters influence how a particular cut, a resection of a polyp is going to happen. So we have learned a lot about electrosurgery, the different types of effects, cut, coagulation, and the different types of current and the voltage and the cycles that determine that. And I hope this is useful. We will learn more about the applications of electrosurgery, how to set up the machine, etc. in the next classes. Thank you.